Kelly did the picture? You're not a real friend. What did you say? Nothing. Turn around, take the notes.
She's better at catching the picture anyway. Figured you'd be thinking like that.
Okay, we are hypothesis testing for population proportions. They usually use a lowercase p to represent population proportion, but because we just got done with the programs and we had a lowercase p value on all of the programs, I just want to distinguish between the two and make this a capital P.
Can we open up window?
I don't care.
No, I'm kind of cool.
Okay. So, proportions are what is making this section different than the other two. So the first thing you're going to have to do is check to see if the sample size is big enough to be normal. And it's not the magic number 30 like it is with means. So check to see if the sample size is big enough to be normal. And what you're going to check is two things. Your sample size times your proportion from the claim has to be greater than or equal to 5. And your sample size times the percent of failures from the claim has to be greater than or equal to 5. If this is the case, your critical values will be z-scores. Okay.
P and Q going to make sense for us?
Yep. It's big P and big Q. So we will be using, so if normal, your critical value is a z-score. So we're going to use inv norm of the left area to get our critical z-score. Your formula to convert your sample proportion into a z-score is slightly different than the last one. So the z-score, do you remember the symbol for sample proportion from the last chapter? P hat.
Negatory.
So the formula you're going to use here is P hat minus the proportion from the claim, divide by the square root P times Q over N.
We can't get another letter in here?
Nope. And so the by-hand steps are pretty much the same by-hand steps. Write your claims. Well, this one you got to first check to see if it's normal. Then rewrite your claims, sketch the graph, find your critical value, turn your sample into a z-score. So it's the same 5 steps as before with the addition of first checking to see that you can actually do it. Do you want me to write that out?
No.
You're good?
Yes.
Knowing that you have to check first and then it's the same 5 steps?
Yes. We're not doing the z-score?
Nope. That's why this is here. So if you wrote this down, I think you'd be fine with the process. Okay. So we'll do one by hand and one by program.
And then that's it?
And then that's it.
Yeah.
We love the end of this semester. Okay, so.
Short, I love this whole year.
Oh, good.
With you.
Okay.
Why don't you say it back?
A researcher claims
Feelings are not mutual.
claims that less than 30% of American adults are allergic to trees, weeds, flowers, and grasses.
How much would you give me if I needed it?
So have allergies. We're just going to go there. We're going to sample 86 adults. We find that 20% have allergies. %20 have allergies. Test this at 5%.
So basically, anytime we see percent, we're going to...
Yes, that's what you've got to pick up on. No, I didn't really say the proportion is, they just gave you the percentage. So let's identify what this 30% is actually giving me. What symbol would I attach to that? Because that's in the claim. What did I give you at the beginning for what the claim is about?
P hat.
Big P, capital P. So this is big P. What's the 20% because that's coming from my sample of 86?
P hat.
That's P hat. So if we just started this one writing the claims, which we'll do, and then we'll check to see if it's normal. I'll show you how you would probably pick up on that on a test. So the claim is that big P is less than 30%.
With big P?
Big P. Making the claim the
Oh, ha.
ha. The ho is that big P is greater than or equal to 70. Okay, so because we've got proportions...
Whoa, why did we change to 7?
Oh, God, I don't know. 30. I was thinking ahead of myself. Oh, sorry. Oh, that was bad. That is still 30.
I mean, it's common sense.
Yeah, I was thinking Q in my head's going to be 70, and then I wrote it down. Anyway, so before we move on, because our claim has big P in it, I have to make sure that the sample size is big enough, and those are the two things that I have to check. So this is the extra step that you have with proportions. And if you forget it, it's going to be minus 1 or 2. So we will check for normal before we move on. Yep. So check for normal. So I need N. Where's my N at in this problem? Which is 86 times big P. What's big P? 0.3. What's 30% of 86? I got 25.8. Which means they probably had 26 successes there out of the 86. And then 86 times big Q. How do I get big Q? 0.7.
What is happening right
I am doing this right here, the very first thing I said. I'm checking to make sure the sample size is big enough to be normal.
now? What is the Q, though?
Somebody want to help them out? Where do you get Q from?
Is that the op? Like
1 minus P.
1 minus P. So that would be 86 times 0.7,
60.2.
60.2, which means they probably had 60 success or
Oh,
failures.
you wouldn't go up 1?
Nope,
Okay.
because you'd want to keep them as close to that percentage as you could.
Okay.
Because these two should add up to your sample size. So 26 people had an allergy, 60 did not.
You don't want.
It doesn't matter. I wouldn't care if you left it. So can we move on? Yes, they're both over 5. Okay? So after we write our claims, if we're doing by hand, what's my next step by hand? Not the formula.
Absorb.
The sketch, the shaded region. Then we'll go to the formula. So my rejection region is going to be where? In the left tail, because ha is pointing to the left. How much is shaded here? 0.05. The alpha is your shaded.
Oh.
0.95 here. We've got a 0 z-score in the middle. To find this z-score, what are we going to do? Inv norm, what? 0.05 gives us a negative
1.64.
could have, I'm going to grab another sheet of paper here. Any questions so far?
Nope, just 1.64.
Yep. Now we're going to use the formula. Because we need to turn our sample value into a z-score to see where it lands. So we need to find the z-score for, what's my sample value?
No, 0.2.
0.2 is my p-hat.
Oh.
So if I follow that formula, it's not quite on the screen.
Equals
So I'm following this. I need my p-hat,
0.2
0.2
minus 0.3
minus 0.3
divided by the square root of 0.3 times 0.7
Very good.
over 86.
Okay, make sure you've got big P and big Q down here. Austin.
So, the 26 and 6 is just checking to see if...
We can actually do the problem. If either of these had come up smaller than 5, we wouldn't be able to do the statistics. We'd have to go back and do a bigger sample.
So, then, the 0.3 times the 0.7, is that just percentages, or could you use 0.6?
No, you have to use the percentages.
Oh, okay.
Alright, George, I got negative 2.02.
All right, let me try it and see what I get. And yeah, it's calculator skills now.
Negative 2.02.
Well, we have an agreement?
Yeah.
Negative 2.02.
We're rejecting hose, George.
You did not get that. You don't have good calculator skills. Let me show you the way.
We are rejecting hose.
So I'm going to start with parentheses around the top. And I don't need any parentheses here because everything's in the square root. So the square root is kind of like its own parenthesis.
Okay.
Is that good? I mean, it's not wrong to put them there. You should still get it even with parentheses. 0.2 minus 0.3 divided by square root. I do need parentheses around. Oh, I wouldn't even need them there either because it's going to multiply before it divides. Okay, so we are in the shaded region because that's 0. That's negative 1.6. Negative 2 is in there, so we're going to reject the hoe.
Yeah. Claim is true, Schwartz.
Claim is true. Oops,
Of course, the one day we're going to finish early, don't bring the book.
of course. And now the program.
What was it?
Well, it's the same as the last one. It's just less work.
A minnow?
What? How many years?
Oh my god. He just said it so calmly though, like it's normal.
It is.
I ate a minnow once. A minnow.
Okay.
Fish do.
Claim.
You got a fish.
5% of American adults, have seen a UFO. Nice. This is what they claim. That 5% of Americans have seen a UFO. Why would anybody care? Okay. We're going to sample.
If you got abducted, you would care.
Okay.
Yeah, you would care. Isn't UFO unified?
Unidentified.
Unidentified flying object.
Okay.
It's not.
8% of these people have seen a UFO.
Ooh. Aren't those people crazy? You watch those shows like in the UP where they've seen Bigfoot?
Test.
UFO or Bigfoot?
at alpha equals 1%.
Bigfoot's 100% real. Matt thinks that he's seen Bigfoot. Not this Matt, but.
Definitely, Bigfoot's not real.
It's-
You can say
No,
It's
like
definitely
literally, I was
real.
like, make fun of him. Like, no, like you're crazy. He's like, no, I saw it.
Okay, start with your claim.
Oh my god.
Okay, I don't see the word mean in there, but I do see a 5%. So what's our symbol that goes with 5%?
What do you also
Big
believe in
P.
P? No.
And what are they saying about big P?
Okay, so the claim would be the big P,
Yes,
and then the sample is the.
little p hat.
Okay.
So big P equals 5%. So they're not saying it's over 5% or at least 5% or it is 5%.
That's the hoe.
It's the hoe.
Now, P is not equal to 0.5% is the ha.
And now, because we've got the P's, we have to check still, even though we're going to use the program, check to make sure that sample size is big enough. Usually 250 is, but we will check before we run into the program.
So 250 times 0.05?
Check for normal. And it's N is 250 times big P.
So it's 0.05.
Yep. What's 5% of 250?
Can you do that in your head?
12.5.
Oops, 1250.
Wouldn't the next answer just be the same?
12.5, which is over 5. And then it's 250 times what? 95.
Seriously?
237.5.
Sounds like an ant.
I thought it did, but I did 238.5, so I lose.
It was, but it was an ant, so.
I thought we were doing one by hand and then,
This is program.
this is program.
Now that we know they're big enough, now we're going to run the program. What's the program name, do you think?
Called prop. The end prop.
Yes, the program is called one prop, not zint.
Oh, okay.
The
One prop,
test.
the test.
One prop Z test. Okay, so let's see what's in one prop Z test that we have to put in. And for the notes, we'll kind of describe what's going in there in case you need it. So,
Okay, Schwartz, do you want to put your calculator on the screen to show everybody?
you don't like looking up there?
No, on there.
Why?
So the people that are taking the notes can see it. 'Cause
Oh.
yesterday,
Oh.
or today when I was taking
Oh.
the notes,
I didn't-
had no idea what you guys were talking about.
Oh, good call. Okay, so stat, over to test.
Oh, my ear.
One prop Z test is number 5. P0, what do you think P0 is?
0.05.
From the whole, yes. You want the whole value here. So that would be 0.05.
X is
What is X on these problems?
Would it be
Is it 0.0?
sample proportion?
8% of 25 or 250?
Yes, X,
Would it be Jesus fish?
no.
No,
X
it's 250.
is the number of successes from your sample. So X is the number of successes.
Move your calculator over.
Yep, number of successes from the sample. How am I going to find out the number of successes from the sample? I did a sample of 250. How many of those people have seen a UFO?
8%.
How do I get 8% of 250?
250 times 8%.
250 times 8%.
Sorry, guys.
What is 250 times 8%?
20.
Is it exactly 20?
Yeah, yes, ma'am.
What if it had come out 20.3?
20.
20. You need a whole number here. If you put a decimal in when you run the program, it's going to give you an error. X must be a whole number here. And you want it to equal the percent, so round normally.
Oh, round number.
Round normally here. So this does equal 20 exactly, but otherwise you would round normally here. Because you want to stay as close to that 8% as you could. Okay, so we're going to put a 20 in that line. And then the number, N is the sample size. Sample size. what would we have, 250? And then it's the ha sign, just like before. What sign do we have in our ha?
It's not equal.
Not equal. And now we go down to calculate. And the same rules apply here as the other two programs. What's the one number I want off of the screen?
Z.
The p, the regular p. The p value from here is the probability value of that sample. So p equals 0.029. Okay, 0.03. And what do we do with the p value to make our decision?
We see if it's,
Compare it back to alpha. How does 0.03 compare to my alpha of 0.01?
It's bigger.
P is bigger than alpha, so it's a good probability. If it's a good probability, what decision do I make?
it's true.
No. I either got to reject the hoe or fail to reject the hoe.
Fail to reject.
Fail to reject the hoe, and that's in your notes from yesterday. It's the same rule for every program. If P is greater than alpha, you fail to reject the hoe.
Do we even have to use this? This is so much more complicated than doing it along with.
Not for everybody.
It's so much longer.
Well, just because I wrote all that mumbo jumbo out, you don't have to write all that mumbo. You don't have to write any of that.
I enjoy the by hand stuff, by the calculator stuff, because I don't know what's good, but.
Oh, well. And then what's our decision about the claim?
Neat.
NEEF. Okay. That's what I have for you. Your assignment then. This is 7-4.
Oh, I thought you were going on with the...
Page 344. Let's go 7 through 10 by hand. And 11 through 13 program.